So welcome back. We're on the last video of chapter 2, so we're continuing talking about some of these graphical methods of displaying data. So the next one we're going to talk about is a stem and leaf diagram. Now, this is something that I remember my kids doing in elementary school, and I'll be honest, it's not something that I see a lot in the real world, but again, I'm not involved in all levels of research. I really just kind of focus on accounting research. So maybe it's more prevalent in other areas. But really, it gives a picture of kind of what, again, the similar to the histogram of how many, what's the count, how many of our pieces of data fall into certain categories. So this is really good with quantitative data as opposed to qualitative data necessarily, but quantitative data where you can take a particular digit and say, okay, all of the data points that start with this particular digit. So for an example, we are given the data of some of the wealthiest people in the world and their ages. So we decided that the digit in the tens place is the stem, and then the digit in the ones place is the leaf. So in other words, what decade, how many decades they are is the stem, and then their individual year is the leaf. So we can graph it that way. So here, for example, we have all the people, and so we decided to use all the people that are 30 in their 30s. 3 is the stem, and we see we have one person who is 36. All the people that are in their 40s, 4 is the stem, but we had 0 people in their 40s. So now we can see all of the people that are in their 50s, and we have 7 people. 2 are 52, 1 is 53, 2 are 54, 1 is 55, 1 is 59. So it's a way to categorize data kind of easily. We can see almost if you turn your head sideways, or if you were to rotate the stem and leaf diagram by, like, let's say 90 degrees to the left, we can almost make out the histogram, right? Whereas the majority of the people are in their 60s. It's fairly symmetrical. We have one person who is exactly 90 though. But again, it gives us some more data than the histogram does. We not just see how many people are in their 60s, but exactly what are their ages. 60, 61, 2 that are 62, 2 that are, 1 that is 65, 2 that are 66, and 1 that is 68, for example. Now, looking at a scatter plot, and I'm going to tell you we're going to come back to scatter plots at a later chapter and really go into a lot more detail. Scatter plots are kind of just the tip of the iceberg of what we use this data for. But this is a way to graphically graph data, like as using our algebra, y equals mx plus b, graphing data on an xy plot, and we can determine whether it is linear or nonlinear. The reason we want to determine if it's linear or nonlinear is to determine if there is a relationship between the two. So first of all, you have to take the data that you have and identify what is the x and what is the y. Remember, when we're graphing, x is the x-axis and y is the y-axis. So you need to determine what is going to be your x and what is going to be your y. So in order to do this, you have to have 2 variables. So we're looking at data that is graphing years of higher education versus income. So years of higher education is our x-axis, and income presented in thousands is our y-axis. So for every person, every data point, we have 2 variables. We have their years of education and then their income, so that we can graph it and see if it is a linear or nonlinear relationship or no relationship at all. So a scatter plot is going to tell us, again, if there's a linear relationship. That a linear relationship doesn't necessarily mean causation. It doesn't necessarily mean that one causes the other. There's more tests that we would need to determine, but it does tell us correlation. Are they correlated together? Is one typically found with the other? A nonlinear relationship could tell us that there's a relationship, but it's not in a direct one-to-one scale. And then no relationship just means that, hey, these 2 data items aren't related at all. So a linear relationship can be upward or downward sloping depending on if it is a positive or negative relationship. So if it's positive, it's sloping up. If it's negative, it's sloping down, like the example here. So some of the data that we might research would be, for example, and I'm just pulling off of some data that I've read before, again, years of education and rates of incarceration. That tends to be negative sloping, meaning the more years of education, the less years of incarceration. Again, not 100%. We're just looking for a relationship between the two. It also doesn't mean that one necessarily causes the other. We'll talk about causation later on. This is just looking at a relationship between the two. So a nonlinear relationship can tell us that there's still a relationship between the two, but it's not increasing or decreasing at a consistent rate. So the reason that this is a nonlinear relationship is because, if you can see my cursor here, notice how it's curved. It's not a straight line, it's curved. So there's a relationship that exists between these two data points, but it's not a one-to-one relationship. It's not a direct relationship. And then it could be that there is no relationship at all, which just means there's no discernible pattern whatsoever. The data points just seem to be scattered randomly. So in accounting, we look at this when we look at the relationship between total cost and output. Obviously, most of the time there's a positive linear relationship between total cost and output, but it is possible to have a nonlinear relationship when we get to things like economies of scale. Now it becomes cheaper per unit to produce as we are producing more units. So as output increases, total cost is increasing, but at a lower rate. So those are just some real life examples. So we're going to skip over now and look at our Excel data. So I'm back in the Chapter 2 workbook, and I am in the edu_inc spreadsheet. So this is education and income spreadsheet. So this is that same data that we were looking at before, looking at years of higher education and what their income is. So in this case, we have a sample size of 8, which we'll talk more about sample size in again a later chapter. And so we can see individual 1 has 3 years of education and income of $45,000, and so on and so forth. So to graph this, again, I just want to grab the data. Now, I don't want to grab the individual. This is just an account, an identifier of individual 1, 2, 3, 4, 5, 6, 7, 8. Those aren't my data points. So education is my X data point. That's why it comes first. Income is my Y education point. It comes second. If you were to flip-flop them, it would graph them the flip-flop way. So make sure whatever you want to be as X is in the first column of your data, and whatever you want to be as Y is in the second column of your data. So I've highlighted my data here. I'm going to go up to Insert, Charts. I still want that scatter plot chart that we've been working in, and now I want this one right here. So I don't have the line in between it. Now you could do it with a line, but look, it gets really messy. That's not really what we want. We just want this basic one right here. And so now again, I can change my chart title, years of education versus income. I can, of course, add axes titles here, which I definitely want to do. So my x-axis is education, whereas my y-axis is income, and this is in thousands. And so now I can see it appears that there is a linear relationship. I could almost draw a straight line. Now I do have somewhat of a outlier here in this person who has 0 years of higher education and yet earns $40,000. That's a little bit of an outlier. Now outliers happen. Outliers are a part of data. So that doesn't necessarily make it nonlinear, but 8 is a very small sample size. I would really want a lot more data. So this appears that it's fairly linear. We could really fit a graph in between the two here. And for those of you that have taken managerial accounting or accounting 2302, this is basically what we do with high-low. We take all of our data. For example, we may take our electric bill for 12 months and the number of kilowatt hours of electricity, and we graph it, and we choose the high point and the low point, and we fit a line between the two. So this is essentially what we're doing. We're going to come back to this again in those later chapters and use linear regression to actually determine the best fit of the line, and then try to determine if there is a correlation or if there is a causation, and what the correlation is between years of education and income. So now you're going to want to go jump into Connect. Make sure you do the SmartBook assignments and the homework. Don't forget there's 2 assignments here. And then in chapter 3, which we'll pick up with next week, we will have one of those Excel simulations. So we're getting ready to start having the Excel assignments come up. Make sure if you have questions that you post those to the discussion board, or you pop by during my office hours, or shoot me an email so that we can have the discussion and make sure that you're really comfortable, especially with the Excel part of it, that you're really comfortable before we get to those Excel simulations next week.